Okay, our next step in our making a power supply is now we've used a transformer to take 120 volts AC and drop it down to something a little safer and more usable. But now it's still AC electricity, and right now I've got this. Let's use the doorbell transformer directly. I'm going to put channel 1. Then one part of the doorbell transformer is connected to here, and the other part is connected to here. So I'm just going to connect that there, and there we have our AC electricity coming in from our power line, being transformed down to about 10 volts or so. That's great, except we need to run our most of our electronic devices. We need DC electricity, so we have to convert our AC into DC, and that's called rectification. And what we're going to do is I've got what I have here is just a diode. This is just a simple diode, and I'm going to connect the other lead of the other channel in, and here's what's coming out of that circuit. So basically the input circuit here is just coming directly off of here, and this here, the negative is still one part of this attached to this, but the positive is now going through the diode, and we can see that now the electricity is just going up, but it's not going back down. And so if I move this down like so, we can see that basically all the negative waves that are coming off of the transformer, the AC, are being clipped off. And so we're getting half a wave, but it's a positive wave. So it's technically DC electricity now. Now it's very ripply DC electricity, is moving up and down 60 times a second, and we're missing part of it. We're missing half of the wave. So this single diode is known as a half-wave rectifier, because it only gives us half of the electricity. And they're useful if you don't need a lot of power and you don't mind losing half of your electricity, because you only have to have one diode, and it's considerably cheaper. But there's another way. Now what I've done now is I've now added 3 more diodes to my rectifier, and they're set up in a special way. Now this special way makes this what's called a bridge rectifier, and what it does is kind of special. Now I still have the AC going in, so if I touch where the AC is going in, we get our AC wave right there. However, if I connect this to the other 2 points of this little diamond, we can see that we're now getting a bunch of bumps, but they're all above ground. So this is DC electricity, and unlike when we did the half-wave rectifier, we're getting every bump. So where the AC was going down, this has flipped it up to going up. So now it's all going the same way. So this is called a full-wave rectifier, and this particular one's a bridge rectifier, and we get all of the electricity. Now it requires 4 diodes instead of 3, but because this is so useful, they actually make integrated circuits. Here's a bridge rectifier, and basically what's on this integrated circuit is these 4 diodes like that. The 2 middle pins here on this particular one, it's where the AC comes in, and then your negative, DC negative, and your DC positive coming out on the sides. So this is basically the best. This is a great way to get all of your electricity.